Okay, good morning, everyone. Do you hear me okay? Yeah. Okay, and just a side note, everyone who's on the left, it's better to move to the center, just so you can see the whole screen. All right, my name is Stanimira Boeva, and I live in Sofia. I'm part of the NativeScript modules team. And today I'm going to show you a few tips how to make your apps start up faster. So in the next almost 30 minutes, we're going to talk about optimizations you can make to make your apps faster, and I'll show you how to profile your startup time so you can see what's slowing you down. So because I'm working on the NativeScript Angular integration, I want to ask you how many of you use Angular? Someone? Okay, that's cool. So everyone knows which of these optimizations are Angular-based, which of them come from the Angular framework? Anyone? Okay, lazy loading and AOT. Okay, thanks. And there is another, the last one, the VA heap snapshots, which is available only for Android. We'll get back on that later. So now that we have some optimization and profiling tools, we just need an app, and we'll make it faster. So I want to present you the simplified version of our SDK examples. And for those of you who are not familiar with it, they look like that. The initial screen is just a list view with examples, and when you navigate around, you see some user interface widgets that look really cool. These come out of the box from NativeScript. And I tested that, and the startup time is almost 13 seconds, which is pretty bad, you know. I started it for Android. By the way, I should mention that I'm doing all of the metrics for Android because I don't have the time to show both platforms, but you can do it yourself if you have a MacBook, of course. And actually, that's how the inner architecture of the app looks like. We have one root module, the AppModule, and several feature modules. And we're loading all of them at startup. If that doesn't ring a bell, we'll show you later how not to do that. Okay, so our goal today is to go down to 3 seconds. From 13 to 3 seconds. But how do we do that? I mean, what's happening in these initial 13 seconds? We need to profile our startup to see what happens. All right. During the development of the NativeScript framework, we created some internal tools to profile the code that's executing inside the framework. Since the last release, you can profile your own apps by adding that key profiling with the value timeline to your inner package JSON. So you go to your project, you open the app folder, and add that key to the package JSON file. Then you should install that awesome package, and you can install it globally because you can use it for all of your apps. And then the only thing you need to do is just run the app in the familiar way, TNS run Android or iOS, and pipe the output to the timeline view, the tool we installed before. We'll see a lot of console logs on our terminal, and when we stop the process, we kill it with Control-C or whatever you like, you have a brand new HTML which is going to be in your project directory. It's called times.html, and you can open it with any browser. So I'll show you how this looks like. It's something like that. That's actually the profiling for our application. So, does anyone know what happens here? I know 10 people, but for the rest of you. So the first thing we do, we start our Android runtime. Also, we extract the app. See, guys, that's why I told you to move in the center. It's too late now. So first we extract the application on the device. That happens only the first time you start the app when you install it. That takes almost 2 seconds, but it's something that happens only the first time. Then we start our V8 engine, and then we start loading the JavaScript modules. So first we start with our entry module, and recursively we load all the node modules like NativeScript Angular and all of our app code, like the entry module and all the other modules. We make a few calls to the file system, and so we just read the files and execute the JavaScript. Then we create our Android activity. Then Angular triggers and starts loading the Angular modules. The code inside the Angular framework is not instrumented with our inner tool, so we see a blank space here. But what we see is the Java garbage collector running. That takes almost 2 seconds, but we're currently working on optimizing that. So you can't optimize that within your app if you're not a pro, but we're working on that, and probably from the next release, you may be able to get 2 seconds faster apps. So what is happening next? We're just setting up the user interface. All right, the loading of Angular modules takes almost 4 seconds, 3.5 in our case, but it can be more if you have a lot of Angular modules. We can drop that to half a second, probably. How do we do that? Anyone? Nope. Nope. Okay, lazy loading is the way to do it. So we have all of these modules that are imported in our root module, and we are loading them because of that. We can stop importing them and just load them when we navigate to a certain page. How do we do that? With 3 easy steps. So I'll show you how to do that for the button module, and you can apply it for every other module here listed here. So first you need to open the AppModule file and provide the NativeScript module loader. It looks like that. Don't try to remember it. Then what you need to do is remove the import of the feature module within the app module. So here we import the button module. We just need to remove that one. And the third step is we need to modify our router configuration using the loadChildren property. Currently, we're importing the app routes, and we're providing them by using the children property. We should stop importing them and use the loadChildren property. We should provide a path to our module and the name of the module. That's all that's needed. So after applying this, for all of our feature modules, we get instant improvement of 3 seconds. Okay, on to the next one. Here I said that we're loading JavaScript modules. We're reading them from the file system, and because we have a lot of node modules and a lot of app code, we're making extensive use of the file system. What we can do, I mean, it's pretty obvious. We can just make all of these files. What? Come on.
One file.
Into a single chunk or a few chunks. So we can bundle them into just a few files and make only 3 calls to the file system instead of hundreds of thousands, literally. So for that, we're going to use Webpack. So who is familiar with Webpack here? Cool, that's cool. All right, for the other ones, Webpack is a module bundler. So it basically starts with a single entry point or a few entry points and traverses all the dependencies of these entries. So we just recursively traverse all of the dependencies of the imported modules, and Webpack creates a dependency graph, and then just wraps all the modules into functions and puts them in a single JavaScript file. Not too hard, right? All right, and if you're using the default NativeScript configuration, I'll show you how later, you have ahead of time compilation for Angular, of course. So the Angular compiler compiles all of the components and their templates in your Angular application. But it has 2 modes. There's the just-in-time mode, which happens while you're using the app. So while you're navigating to your pages, the Angular compiler just triggers and compiles your components. And then there's the ahead of time mode. When you build your app up front with ahead of time enabled, you just have your components compiled into executable JavaScript, and when you ship your app to the user, it doesn't have a compiler in it. So that's the biggest optimization, because the Angular compiler is like 1/3 of the Angular framework. If you drop that chunk and you compile your components, you get an instant performance boost. All right, so how do we use Webpack with NativeScript? We have to install, of course, you don't have to, but it's better if you don't want to suffer too much. You have to install the NativeScript dev Webpack plugin and save it as a dev dependency. And because that adds a few other dependencies to your package.json, you have to run npm install once again. All right, that plugin also adds a few files to your project. You should keep these under source control. They're all Webpack configurations, and I'll mention how to use them later. So after that, you need to run an npm script instead of TNS, and you should type start or build Android bundle. And of course, for iOS, it's start iOS bundle. So let's do that. First, I need to install the NativeScript dev Webpack plugin. -D is the same as --save dev, so it's just shorter. Just use it. And while we are styling it, I should run npm install once again. And I'll just have to wait, but because I've done that before, we won't wait for too long. So the Webpack plugin adds Webpack itself and a few other Webpack plugins and loaders. So now we're gonna use the npm run build Android bundle and just start our app. If you want to profile it, we should pipe the output to the timeline view again. It's as simple as that. All right, I'll start it. We'll wait for a couple of hours. And what does command do? It just prepares the native Android project, then it bundles our JavaScript files, and then it ships the app on the device. And a couple more things, but never mind. So this here right now, Webpack is running. It's going through all of our dependencies, our node modules, and bundling them into a single file. So we fail miserably, and because this is a node script, an npm script, we don't see the actual error. So what you need to do in these situations, scroll back, scroll a little bit, even more, and here are the actual errors. Okay, I'm prepared for that. I even have slides. So I'll spoil it for you that these are errors from the Angular ahead of time compiler. Because we're compiling our components at build time, we see errors that otherwise we won't see because they will be disabled at runtime. So the first error, as you can see, we have a component with a single method definition, the onTap method. And in our components template, we are invoking that by providing one argument. So don't read the error. We have method declaration that accepts 0 parameters, and we're invoking it with one argument. So what we need to do is just drop the argument we're passing. That's all. That's how we fix it. And you can see the error again. It's called supplied parameters do not match any signature of code target. It's not pretty obvious, but that's how we fix it. And we have a second error. We have a single property that's defined in our components class, and it's private. We're using that in our components template, and every property that we're using in the components template should be public, obviously. So that's how we fix it. All right, after we run that again, we get a startup time of 4.1 seconds. Trust me. All right, so how did we drop almost 6 seconds from our startup time? First, there's the extracting of JavaScript assets. Because we dropped the Angular compiler, we have a lot less code, like almost a megabyte less code. So the extracting of our app on the device takes 200 milliseconds, right? Okay, and also we have a lot less JavaScript files. I'll show you how many, but trust me, it's less than 10. Okay, and that takes almost 3 seconds less. And of course, we don't have the Angular compiler that's running, so we don't have compilation of any components. And the result is, faster app. It's worth it. And then what we can do even more is jump on the next optimization without introducing it. Never mind. So that's Uglify.js. So who is familiar? No, let me ask you that. Who wrote that JavaScript parser? Anyone? Okay. By the way, he works for Progress. Woo! You can try to find him later. He's not here on the web, I mean. All right, so Uglify.js is a JavaScript parser. It's the whole thing it does is just optimize your JavaScript code and make it really faster. It does minification, like removing all the white spaces, improving your statements and expressions, making them faster because it knows how to do it. And it does name mangling. It just renames your variables with shorter names. So the result is smaller and faster, really optimized JavaScript code. And of course, it does that awesome thing called tree shaking that's available in Webpack with Uglify since version 2.0 on. And what it does, so let's imagine we have a JavaScript module. We have 20 exported methods in it. We have one more module, that's all of it. So we have 2 modules in our app. The other module is importing only 5 methods from the first one. Obviously, the other 15 methods in the first one are unused. So Webpack is going to mark these methods as unused, and basically mark it adds just comments above them. That's funny. And when you run Uglify.js with compression enabled, Uglify.js is going to remove all the unused exports. So that's tree shaking in the context of Webpack. All right, how do we run Uglify.js with NativeScript? We just have to pass the Uglify flag to our previous command. After we do that, we get, skip this, we get 5 seconds less. That's because, of course, our app is smaller and it's more optimized. All right, go back. Why don't we have Uglify.js by default? Because that's how uglified code looks like. Try to debug that. You can't. All right. So on to the next one. We can do better, but let me introduce you another profiling tool. So, do you know what's coming up next? Anyone?
Webpack something.
Webpack something. That's right. So, let me introduce you to Bundle Analyzer. It's pretty cool, and it's included in your Webpack configuration by default if you install the NativeScript plugin. So when you run npm run start or build Android or iOS bundle, that Bundle Analyzer generates a directory that's called reports. It has 2 files in it. We're going to talk about the first one today. It's an HTML file, and when you open it, you see this. You have no idea what is that, right? Well, that's your app after Webpack runs through it. You have different JavaScript files here. They're marked in different color. And the first one, vendor.js, has some external modules. It's basically a common module that we can use to put common things there. And we can use it for other things too. We'll see later. By default, we have NativeScript Angular, the Angular framework, and our core modules included in vendor. And it's definitely a lot bigger than the other chunks, as you can see. Also, we have our app code that's separated in a few other modules. The first one, which is called bundle.js, is our entry module. We start the app from there. On startup, we load only the bundle.js and the vendor.js. And also we have several other modules that are our lazy modules. These are loaded when we navigate to a lazy loaded page. All right, so how are we going to use that information? We're going to use the V8 heap snapshots. So just step back. For our Android runtime, we are using V8, which is a JavaScript engine used also by Chrome and Node.js. And V8 provides us that awesome feature to just start and serialize a JavaScript code in an empty context. Okay, in simpler words, we have JavaScript, we execute it at build time, we serialize the output to a binary, And when we want to start it, it just loads instantly. So we're using that with Webpack with a plugin we wrote. So we are just making a heap snapshot of the vendor.js chunk, the biggest one. Then we're generating our application, and so we're including the binary file there. So how do we do that? We do it by passing the snapshot flag again, just like we did with Taglify. And the result is 7 seconds faster app. So we're already down to 2.9, right? Isn't that cool? But what if I tell you you can do better? All right, so how to improve that? When we install the Webpack plugin, it adds a vendor.ts file to our app folder. Here we have requires for NativeScript Angular, and of course the TNS core modules. These are all the modules that are included right now to the vendor.js chunk. So what we can do is just put more stuff there. And it's going to be snapshotted and loaded instantly. What we can't do, just to mention, for our snapshot, we're just executing raw JavaScript. So we don't have access to native Android APIs. So if you have something like Android widget button, we have to wrap it so it's executed lazily at runtime. That's it. So that's our app. We're looking right now at the bundle.js chunk. That's the small one that should contain only app code. But you can see that it contains NativeScript Angular animations. And that's not our fault, actually. But what we can do is just import the NativeScript Angular animations in our vendor.ts file, and then they will go to the vendor chunk, right? Does that make sense? You can stop me at any time. All right, and so that's how it looked like before. It was almost half a megabyte, and when we move the NativeScript Angular animations, it's 15 kilobytes and contains only our AppModule. And that's AppModule engine factory because it's already compiled. So the startup times drops to 2.6 seconds. Okay, what else we can do? We can look at our lazy loaded chunks. They have something in common, as you can see. That's the list view. All right, in our app, I'm using TailoredQI list view, which is free from yesterday, by the way, just to mention that. And because I'm using it in a shared module, and I'm importing that shared module to all of my chunks, all of my Angular lazy loaded modules, it gets replicated. What I can do is just extract it to the vendor chunk, which is the place for shared modules. So I just simply need to add these two lines, and because I know I need the second one, I just add it. Go figure out how to do it. Okay, you can ask me later, I'll show you. But I have only 30 minutes, so never mind. So this is how our lazy loaded chunks look like. They're dropped with another 100 kilobytes, and we have something else common here. As I mentioned, we have a shared module. That's a pure Angular shared module that we use to re-export commonly used engine modules like NativeScript Forms or NativeScript Router module or some other reusable components. So what we need to do is create an export file, an index.ts file in our shared folder, and export everything that we're using in the shared module. Then we can simply require that in our vendor.ts chunk, and the shared module is gone. All right, so we drop that with only 10 kilobytes. It gets worse, so I should stop here. We can't drop anything else. Okay, we can, but you can do that later. If you drop the... Okay, there is a secret slide here. I won't show it today, but if you drop that to, let's say, a second and a half, you receive swag. Okay? But you have to do it at the conference. Cool. So our lazy loaded chunks are 40 kilobytes. Our time is improved with 300 milliseconds. And that's where we're stopping today. So is that okay? 2.6 seconds. That's on Nexus 5, which is... profiled that on Nexus 5, Android level 21, I think. Or that, never mind, never said that. So that's a 4-year-old phone, Android phone. You can do that, these profilings on iOS, and the final results are even better. So let's wrap it up. What we did today, and we had a few optimizations to profiling tools that you should use. And yeah, just do that. If your app is slow, use the timeline view. It's nothing more than installing one npm package, adding a single key to your package.json, and just generating a report. Also, just if you're doing NativeScript Angular, use lazy loading. That's an amazing feature that's provided by the Angular framework. It's really hard to implement, just use it, and your app will be faster. Also, use Webpack with Uglify and Snapshot for your release builds. Please don't use them for debug. The building takes more than a minute, and you don't have wirefsync yet. But that may change in the next few months or years. All right. So what I suggest to do is just use continuous integration with Travis or Jenkins, and just release your app daily to the App Store, or at least do release builds every night, just to see if you haven't messed up something the previous day. And also for detecting ahead of time errors while you're doing your release builds, you can just use CodeWiser, which is a tool for analyzing your Angular code, and you can detect these errors upfront while you're developing the app, even in debug mode. CodeWiser will show the errors, and you will be able to fix them before they're more than 10. All right, so that's it. You can get some free resources. It's just a couple of blog posts. They're free anyway. And if you have questions, I can answer them. All right, anyone? It's up to you to make a default. In my opinion, none, but they just created it later. And in the Angular documentation, I think it's the first one that's mentioned, but I'm not sure about that. But yeah, just use lazy loading up front. Don't create 15 Angular modules and just try to refactor them later. It's a pain. Yeah. Been there, done that. I mean, 40 modules refactoring. All right, anyone else?
Why do you provide NS module factory loader for ng module factory loader?
Well, because the module loader that comes from Angular is using system.js by default, and that doesn't work for us. We're just doing require. We're not doing system import. Yeah, that's why.